So now we're moving into subtraction. So subtraction, we have 368 minus 157 equals to 211. And so we can write out our polynomial that might go with that problem. So we could write it for number 7 as 3x squared plus 6x plus 8. And underneath that, we have 1x squared plus 5x plus 7. And if we are going to be doing a subtraction problem, we want to make sure we're kind of putting that in so we don't forget we're doing subtraction instead of addition. So our problem would look like this, and you can see how similar it looks to the regular subtraction problem. And so if we do 3 minus 1, we get 2x squared. 6 minus 5 is equal to 1x. And 8 minus 7 is equal to 1. And that matches the answer here. So it is showing that when we're doing subtraction for polynomials and expressions like these, it is very, very close and almost exactly the same as it might be for polynomials compared to regular whole numbers. So we can get rid of that and move to our next slide here. And we're looking at just an example of subtraction. So you can see where it says it can easily lead to errors if you don't carefully keep track of your positive and negative signs. And one way to do that is just to, when you're subtracting, when you subtract a negative, you're actually adding. So you can change those to just plus signs. And when you subtract a positive, you're actually just subtracting. So you can change that to just a minus sign. So you can see that's what happened in this top example, where you're subtracting 2x cubed minus x squared plus 6x plus 8. So when you subtract a positive, you're actually just adding a negative. Subtract a negative, you're just adding. And you can see everything kind of switched to the opposite sign. For horizontal subtraction, you can get your answer. You can also make it line up, take step 1, what they did right here, and bring that down and just do it vertically once it's addition, and you get kind of the same thing. So we can use this basically no matter when we want to when it comes to subtraction. We are now looking at 4 different subtraction problems. So let's work through these together, and then we're almost getting towards the end of our lesson today. So to start with, in part A, number 10A, is we're going to do h, 4x, this 4x squared polynomial minus k. So we can do, we'll just do it down here at the bottom. So we have 4x squared minus x. Whoop. Let's try that again. Minus x minus 15. And we are going to subtract that by negative x squared plus 7x plus 4. So the way that I like to do it is kind of keep everything horizontal for subtraction, because we know we're going to write this second one as everything being the opposite. So I'm going to write this second one as plus x squared minus 7x minus 4. And then the first part hasn't changed at all since we didn't do anything to it yet. And we can just write it the same way. And so that means we have 4x squared and a positive x squared to make 5x squared. And we have negative x and negative 7x is negative 8x. Negative 15 and minus 4 is negative 19. Working on part B of this problem, we are doing f minus h. So I'm going to do x cubed plus 2x squared minus 7x minus 8. And then I'm going to subtract the h part, which would be 4x squared minus x minus 15. So I'm going to now subtract the 4x. So all these second parts are become the opposite. So I have negative 4x squared, and I have a positive x, and I have a positive 15. And then the first part hasn't changed, so I have x cubed plus 2x squared and minus 7x minus 8. So I can now write my answer. So I only have one x cubed term, so x cubed is by itself, and we can just write that down first. I have 2x squared and negative 4x squared would combine to make negative 2x squared. I have negative 7x and positive x would make negative 6x. And negative 8 plus 15 would equal to 7. Moving on to part C, we have f, which is x cubed plus 2x squared minus 7x minus 8. And I'm going to put that in parentheses, and then I need to subtract g. So I'm going to subtract negative 4x minus 7. And so now that second part will all become the opposite. So I'm going to be adding 4x and adding 7 to the prior polynomial. So I have the first two terms exactly the same. So I have x cubed and 2x squared unchanged. But then I have negative 7 plus 4x is negative 3x. And then I have negative 8 plus 7 is negative 1. And that finishes part C of number 10. And lastly, let's do part D of number 10. So we're going to do k, our last polynomial, subtracting our first one. So this is a little bit different because we have 3 things minus 4 terms. So let's make sure we're taking our time with this. So we have k first. We have negative x squared plus 7x. And we have plus 4. And we are going to be subtracting function f, which is minus x cubed plus 2x squared minus 7x minus 8. Now the second one, we're going to turn into the opposite signs. So I have negative x cubed minus 2x squared and a positive 7x plus 8. And so now we're going to put all of this together and look for the common terms that we have. So we can all even just put it all on the same line here. So we have negative x squared plus 7x plus 4. And all we have to do now is just combine all of the like terms together. So let's do that in our answer space over here. So if we're looking through all of this, we only have one x cubed term. So that can go in first. We have negative x cubed. And we have two x squared terms, 1 and 2. So negative 1 and negative 2 is negative 3x squared. And we have a x term and an x term. So that would turn into a positive 14x, because we have k had a 7x, and we subtracted f, which had a negative 7x, so we got 14x out of that. And we have 4 plus 8 is easy, and just 12. So there are 4 different subtraction examples of varying levels of difficulty as great practice to walk through this process. So now we're looking at a similar graphing problem as we did earlier with addition, but now we're working with subtraction. So we can draw in our x and y axis first, and we are going to plot our points. So we have 0 for x would be, we have a 2 and a 1, so 2 minus 1 is 1. We go over to the right one to x equals 1, we have 3 and 0. So we have 3 minus 0 is equal to 3. And you go one more over to the right. At 2, we have a 4 and then a negative 1. So 4 minus negative 1 is actually 4 plus 1. So that would be equal to a 5. And you can see we start to have a line forming here. So let's go to the left by a space to negative 1. So we have 1 and a 2. So we have 1 minus 2 is equal to negative 1. And now we can see we have a constant slope here. So we can just draw our line here, and then we can kind of keep following that same slope if we wanted to draw a really accurate line. So we can see that if we take a linear function like L of x over here in the left, subtract m of x, we end up with a line looking like the one right here on the right-hand side. This final problem is more of an application word problem that has to do with combining different expressions together. So please take a second to read through the word problem and try it for yourself while pausing the video. I will make the assumption that you have paused the video and tried it by now. So let's look at our answers here. So if we are looking at drawing a rectangle, we don't know the width of the rectangle, but we can also write that the length is 6 feet more than the width. So we have the width of the rectangle is these two sides opposites of each other. The length is the other two sides, and they're 6 feet more, so plus 6 on those. And when you're doing perimeter, which we can kind of underline, we're doing a perimeter problem. A perimeter of a rectangle is adding up all 4 sides together. So if we added up the 2 widths and then the 2 lengths, they have to add up to 52 feet of this trim material they need to make the rectangular trailer. So we can combine these 2 W's into 2W, and then we have 2 of these parentheses, or you could just kind of add up all the W's, which there are 4 of them, and then add up the 2 6's, so it's 12. And you end up with an expression like 4W plus 12 equal 52. Use our solving equation skills to solve for W to find out that 10 feet would be the width of this rectangle. And then if the length is 6 feet more than the width, that tells us that 16, which you can see kind of right here, 16 would be the answer to this problem. And that is adding and subtracting polynomial expressions. Thank you for watching this lesson.